My talk is called The Free Will, Observers, Their Contexts, Quadratic Events in the Human Thinking and MEMS. Yes. But I am not able to. Yes, experiments. I think that it is important to understand what is the observer's role in the real experiments. Because the question of the free will, I think, is the question what is the relation between observer and the experiment. Then the abstract description of the experiment is the following. There are first two steps. Step one is contains the plan of the experiment, which specifies all details of the future experiment. Step two, the decision that this planned experiment will be run at a certain time, or times when it is repeated. These two steps evidently depend on the free will of the observer. This dependence is evidently true both for classical experiments and for quantum experiments. There is the second, in fact, the third slide. There are the second part of experiment. Step 3, the definition of the set of possible outputs of the experiment. This depends on the step 1, of course, and the calculation of probabilities of outputs. This is understood as a prediction based on the rules of quantum mechanics. Step 4, the realization of the experiment is repetition and the calculation of relative frequencies of outputs. Step 5, the comparison of relative frequencies with the predicted probabilities. This means the conclusion of the experiment. I am sorry for the description of rather trivial description of the experiment, but this trivial description implies that the role of what is the role of the observer in the experiment. These are first two steps. Step 1 and step 2. These pieces of steps are clearly defined as an explicit behavior implied by the free will of the observer. The question of the connection between the free will of the observer and the physical experiments stays in these first two steps. So I think that the real steps, I'm sorry for the rather trivial observation, but the role of the observer in the experiment is that one. This is very important because it sees that our questions about what is the experiment and what is the free will of the observer is defined by these first two steps of the experiment. Next slide. It is clear that steps from 3 to 5 do not depend on the free will of the observer. These steps may be realized by the automatically machine which was constructed before and which needs only to obtain the necessary input data. But these input data are uniquely determined by steps 1 and step 2. Thus, the rest steps 3 to 5 can be completely automated and do not need any action of the observer. The main step, the calculation of probabilities of possible outputs, follows from quantum mechanical rules. The important now I will enter into the details. The important part of the definition of an experiment is the exact definition of a context of the experiment. The concept of the context K of an experiment E is based on the concept of a new quadratic model for events. The construction of the context proceeds in the following steps. First, the classical model for linear events, the new model for quadratic events, possible incompatibility of events, the context of the experiment, universes defining the context. Now I will come to the new part of the observation concerned with the the concept I would like to discuss. Excuse me, but do you hear me?
Yes, I do.
Yes,
I can hear you quite well. No problem. I think
no
that the
problem.
remaining.
So that I can continue. I was without the response from you. Then I can continue quietly.
Yes, go ahead.
Yes, thank you very much. The general concept of an event. The concept of an event is the basic concept in science. The science considers events, their properties, and relationships among them. This is general statement. The fundamental question is then, what is the mathematical model for the set of events which is used? The classical idea is the following. The set of events are modeled as a set of subsets of the basic set omega of elementary events. This is true for the classical Kolmogorov compatibility probability theory and also for the classical logic. Now, I would like to present here a new concept of quadratic events, which gives the base for the probability theory of quadratic events, which is, in fact, the real base of quantum mechanics. And we present also a new model for the post-classical logic based on the logic of quadratic statements. I will repeat the concept of a classical. I shall call it linear events. It is assumed that there is a defines a set of all elementary events denoted omega. We shall assume for the simplicity that omega is a finite set. Classical events are modeled as subset of more precisely. The set of events is a set of subsets of omega, which is closed with respect to operations of unions, intersections, and complements. Such set of subsets of omega is called the linear algebra. This algebra is the basic concept of the Kolmogorov classical probability theory. In fact, I would like to remark, the Kolmogorov probability theory, of course, uses the general infinite set of omega, so is very much more technically, mathematically, much more complicated than things which are explained here. I am explaining here, remembering here. Now, I would like to introduce of a quadratic event. The quadratic subset of omega is the subset A of omega. Together, this is the composition. The decomposition is A1 to AN such that subsets A1 to AN are mutually disjoint and the union gives A, capital A. The meaning of this decomposition is following. This is important. If X and epsilon, Y are elements of the same RE, then they are considered as indistinguishable. As if they are considered as distinguishable. If they are elements of different parts AI. As an example, there is a classical decomposition. This is one-point decomposition. The set A, capital A, is union of one-point sets X for any X from A. The opposite, the most general decomposition, I would like to call it generalization of A, is A equal the set, one element set with the set A1, where A1 is covers all the A. This element is annoyed by the indistinguishable union of A. So that the general event denoted A1, the set of A1 up to AN, can be written as generalization of A1 union up to generalization of AN. So that this is the set of the quadratic event.
Hello there. I don't know if it's just me. I'm not getting any sound at the moment.
Yes, it looks like we lost Dr. Soucek. Hello, Dr. Soucek, are you there?
It's been I see only I am seeing only my slides and not anything else.
We can, I think all of us, we can see your screen, and now you are at the concept of quadratic event.
Yes, the concept of a quadratic event.
And you were at the bottom of your list.
Yes. Do you hear me also?
Yes, I think everybody can hear you.
Yes. The last line is that the events which is composed from one set only are called atomic events or atoms. This is opposite side with respect to the classical event, which are composed on one-point sets. This atomic event is composed from one set containing all the points of A. Now, the basic change in the probability theory and also in the logic stays in the fact that instead of the concept of linear events, it is used the concept of quadratic events. The name quadratic events follows from another mathematical representation of this set, which is not important at the moment. So the quadratic event is a subset of omega, but divided in parts. Subset plus the decomposition of the event into parts. Now, there is the basic definition. Two events, A and B, are compatible. There is a symbol for this being compatible. If for each part, AI and BJ, if these parts are intersecting, so that their intersection is different from zero, then these parts must be the same. So this means that two events are compatible if on the part where they intersect each other, these subsets are the same. Now, the basic postulate. In a given experiment, only mutually compatible events can be observed. This is natural, since in a given experiment, it is not possible to observe.
Ok, c'est bon.
Is it okay, my presentation?
Can you hear me?
Yes, I can hear you.
Yes. Who is speaking now?
Yes.
I am here.
Yes, now Dr. Soucek is speaking, and hello, Dr. Reznikov. You're welcome, but could you please, at this moment, turn off your microphone and enjoy Dr. Soucek lecture?
Yes, good. No.
Thank you.
So, can I continue, or should I?
Yes, please, Dr. Soucek, please continue. Please continue your presentation.
So, the main assumption is that in the linear model of events, these two events are more or less compatible. While in concept of a quadratic event, the two events may be compatible or incompatible. It depends how they behave one to another. The definition is written on the slide, upper part of the slide. Now, the basic postulate with respect to the interpretation in the quantum physics is that in a given experiment, only mutually compatible events can be observed. Let us define the context as a maximal set of a mutually compatible events. This means that the context K is something which should be corresponding to an experiment, because in each experiment we should define what is the set of maximally mutually compatible events, and this is called context of a given experiment. Now, this context can be characterized by universes. The definition is the universe is an event such that the support the universe is an event satisfying the support its support, this means the union of these parts from which it is composed, is all omega. For each context K, there exists a unique universe U which generates K in such a way that K, the context, is a set of all events compatible with U. If you take the context, then in context is the linear set algebra in omega, closed with respect to union, intersection, and composition. Now, this was the abstract part, definitions of the quadratic events. I would like to explain this on an example where the meaning of these abstract definitions will be clear. The example is two-slit experiment, well-known two-slit experiments in quantum mechanics. The two-slit experiment contains in general two slits and then a screen. There is a source, two slits, and a screen. I shall suppose, for the simplicity, that a screen is composed from a finite set of points of capital X. Then the set of elementary events is union of two sets. The first set is events where the particle is going through the first slit, E1, X, and arriving at the point X. The second part is particle going through the second slit and arriving at the point X. This is the set of elementary events. Indices 1 and 2 denote the slits through which a particle has passed, and X denotes the point at the screen where the particle has arrived. Now, it is into consideration the information, so-called which-way information. Which-way information is information specifying if particle has passed through the first slit or respectively through the second slit. Well, the probability of the arrival at X depends on the fact whether the which-way information is available. This is the famous description by Feynman. The fact that the result of an experiment can depend on the existence, respectively the absence, non-existence of a certain information is rather strange because we are habituated to expect that the result of physical experiments depends on the experiment, not on the some existence of some information. Now, I will do the explanation of this, description and explanation of this fact. The next slide. In the language of quadratic events, this situation is not strange. We can consider the two different events. First event is the A1x union with E2x, which is a distinguishable union. This means a distinguishable passage through slits with the arrival at X. There is a second possibility. A1x, distinguishable union with A2x. A1x, indistinguishable union with E2x. The indistinguishable passage, this means the event of the indistinguishable passage through slits with the arrival at X. These are different events in the quadratic model. So it is clear that probabilities will be in general different of these events. The explanation is simple. It is natural that probabilities of different events may be different. In fact, there are two different contexts, K1 and K2. K1 is generated by the union of all distinguishable passages of X, while the U2 is generated by the indistinguishable unions of passage. While the U2 is the standard quantum mechanical context, this means without the Wijkvey information. The U1 is the context with the Wijkvey information available. Here, K1 is the context corresponding to the existence of the Wijkvey information. This means more or less the classical situation, while K2 is the context corresponding to the absence of the Wijkvey information, which is the situation of the quantum mechanics. I would like to remark that the true problem of the two-slit experiment is not the existing interference, which is well known, this interference, but the true problem is the dependence of results on the existence, respectively absence, of the Wijkvey information. In the quadratic model of the quadratic events, this can be explained simply because these experiments, two experiments, are different. In first experiment, it is given observed in the context K1. In the second experiment, it is observed in the K2. So the concept of quadratic events offers the elegant, I think the unique possible solution to this problem. To each experiment, there must be specified its context. The same experiment with different context gives different results. The exact specification of the context of the experiment must follow from the exact specification of the experiment. I'm sorry. I will return to the references. I shall return to the references. Sorry. Now, what is the relation to the free will problem? I would like to generalize the free will problem to the more general consideration. This is the relation between quantum mechanics and the logic of the human thinking. There are many proposals. There are now in the last years many proposals which would like to find some relation between the logic of the thinking with the properties of quantum mechanics. And I would like to generalize this question of free will, I'm sorry, to the more general question, what is the relation between quantum mechanics and the logic of human thinking? My main conjecture is the following. The similarity of some features of quantum mechanics and some features of human thinking is based on the fact that both have the same origin or background, and this origin is the theory of quadratic events. So that I think that the relation between quantum mechanics and human thinking are not the direct relation, but is it is a relation composed from the fact that quantum mechanics is based on the theory of quadratic events, and human thinking is also based on the theory of quadratic events. This means that there is no direct connection, but that these two domains have some common background. Our first step consists in the explanation what are events in logic. Only then it will be possible to compare events in the logic to events in the probability theory. At this moment, I have explained what is the role, briefly, but explain what is the role of quadratic events in the probability theory. It means in the probability theory of quadratic events. This means the base of quantum mechanics, but there is other part. What is the role of quadratic events in the logic? This will be the next part. The logic, I will start with the standard logic, and then I will generalize it to the logic of quadratic events. The logic of linear events can be briefly explained in the following way. The starting point is the set of elementary. I will simplify the situation as the maximum. The starting point is the set of elementary statements, call them S1, Sm. Let me assume that this is a finite set. Let sigma be any map from the set 1 to m into set 1, 0. There are 2 up to m of such maps. We denote S1 up to 1 is as Si up to 1 is equal Si, and Si up to 0 is equal the negation of Si. Then the set we can construct the set S up to sigma, which is S1 up to sigma 1 conjunction up to Sm up to sigma m. These are the set of S sigma is the set of all elementary conjunctions. All elementary conjunctions are conjunctions of elementary statements or negation of elementary statements. This is a set of all. Omega, the set of events, is defined as the set of all S up to sigma. This means the set of all possible elementary conjunctions. Its cardinality is n equal 2 up to m. Let V is a set of truth values. 1, 0. 1 is true, 0 is false. Any map which defined to each from the set of elementary statements into the B is called also evaluation. This is a standard way in the logic. This means that to each elementary statement there is a number 1 denoting the truth of these elementary statements, or number 0 denoting the falsity of elementary statement. Now, the basic result of the standard propositional logic, classical propositional logic, is that each statement can be expressed as a subset of omega. This way is called the normal form of the statement. This means the normal point theorem. This means that every statement is equivalent to the subset of omega. In general, if E1 up to Ek is a set of different elementary conjunctions, then their disjunction described as set A, and for different choices, this represent all statements. This is the standard normal form of the statement as the disjunction of elementary conjunctions. We call elementary conjunction equal to equal an event. This is a new term for the elementary conjunction. Now the similarity between the standard probability theory and the standard propositional logic is clear. Both are based on the algebra omega of elementary events. In probability, this algebra of omega is defined directly, while in logic it is defined as a set of events, all events, or equivalently as a set of all elementary disjunctions. So we see that there is certain similarity. Now, this was description of linear events in the logic. Now, the description of quadratic events is analogical to the quadratic events in the probability theory. So that we can consider all these concepts from the quadratic set of quadratic events or probability based on quadratic events. This means the concept of a context K of the universe. Now, in logic, the situation is slightly more complicated, that it is not sufficient to consider a given context, but it is necessary to consider also our other events. Now there are definitions. For two events, A and B, we define A is smaller than B if each part of A, AI, there exists Bj such that AI is part of Bj. We call this that B generalizes A. The second definition is that E generalizes G is smaller than B weakly smaller. The definition is if there is a situation that some part AI and some part Bj are intersecting with the non-zero intersection, then it is necessary that AI is part of Bj for all such I and J. This is called that B weakly generalizes A. In fact, to have an idea, A is smaller than B is equivalent that A is weakly smaller than B, and that the support of A is part of support of B. For a given universe U, we define the quadratic context generated by U that this is the set of all A, which such that universe is weakly smaller than A. This is a rather abstract definition. It is necessary to see many examples and to understand exactly what this means. The definitions are exact, but it's rather short. This means that if you have a universe defining the context you may take any parts of this universe and you can construct not only unions of these parts, of some of these parts, but also the union and then the generalization. This means the indistinguishable union of these elements. And this is what is called the quadratic context. K upper subscript Q. The reason why we continue in this way is that the human thinking clearly uses freely the way of generalizations. This is something very common in in logic. This is described as the lambda operation. This generalization is called the. This is studied in the lambda theory of lambda operation in logic. Thus, a given universe generates two contexts: the standard linear context, which is union of pieces of the U, of some pieces of U, and the quadratic context, which contains moreover any indistinguishable unions from the pieces of K. The quadratic context contains all generalizations which can be associated with the linear context K. Now, the general fact is that two universes are compatible if and only if they are equal. The definition is two universes U1 and U2 are called weakly compatible, denoted by the compatibility with a superscript W. If U1 is smaller than U2, or U2 is smaller than U1. In fact, the quadratic context is the union of all linear contexts which are in KQ. Now, the important thing, what makes this quadratic context and quadratic events interesting. As a consequence, we obtain that there in this quadratic logic, there are two types of the incompatibility. The first part of the incompatibility is described on this slide. Each person has its context through which she understands her world and its valuations through which she associates truth values to statements. We say that two persons' views are weakly incompatible if these two persons started from the same context, but their valuations differ. This is weakly incompatible since this is like that I think that tennis is a good sport and another person thinks that tennis is not a good sport. Well, this is incompatibility between our views, but this is weak incompatibility because we are completely able to understand each other, because the incompatibility is only in the valuation, not in context. In the same context, we both consider same. the sports and things like this, and we are different valuations. This is mutually understandable. This is incompatible because I think that it is okay of tennis. Another person thinks that tennis is not interesting sport. Well, the main definition: the two persons' views are strongly incompatible if their contexts are different. If two persons have different contexts, then their mutual understanding is not good. It cannot be good because every person thinks and sees the world in another terms. One, for example, is interesting in sports, and one is not interesting in sports, is interesting in other things, in playing the plays on computer. So these persons have no reasonable intersection with their views. So the weak incompatibility means that both persons can understand each other and tolerate each other, while the strong incompatibility means that these persons cannot understand each other since their basic concepts are different and incompatible. This is a novelty. In the classical world, only the weak classical logics, only the weak incompatibility is possible. While in the extended description of the logic of quadratic statements, there are possibility of the strong incompatibility. This is a new phenomenon. The fact is that in some general point of view, that the person's valuation can change smoothly and rather quickly during its lifetime. This is quite common. On the other hand, the person's context usually does not change in this lifetime. The person's context may be considered as an approximately constant and associated with a given person. The different context of two persons implies that their valuations and worldviews cannot be compared. In some sense, these persons live in the different intellectual or cultural worlds. There is some imagination of this incompatibility. In fact, their mutual understanding is impossible. Now, the situation depends on details. What is the relation between the quadratic context of the first person and quadratic context of the second person? This needs more detailed investigation, which can be done simply.
Knowing that, still a lot of work to do, and I'm very proud already with my season so far. So I just need to still, play and continue.
Well, I'm sure you're going to have enormous support. So well done on another fantastic week. Petra Kvitova. Thank you.
So, can I continue? Probably I'm not sure. In some situations, the context means something similar to a paradigm. But the paradigm usually is not associated with each person. This is associated with some theory and things like more general objects. Now, the context of a person and the valuations can be heredited, but the valuation is smoothly changing during the life. So the heredity of the valuation has no direct meaning, while the contexts are not changing. The context of a person is not changing in general, or not often changed, so that it is possible to consider the heredity of the context. The context is a relatively stable feature associated with a given person, while the evaluation is changing. The classical logic does not offer the concept of a context, but the difference in context is important. Each person lives and sees the world in her context. This is strange, but this is some person may have one or two or three contexts in his life, say this is true. This is not the exact definition, but generally not. Her context may contain opinions, idea of the world, underground assumptions, prejudices, improved general ideas, and so on. I think that contexts are inherited from parents to children in young years of the life, between 2 to 4 years, I think. In fact, context of parents are combination. There is a certain combination of context of the father and the context of the mother. So this is a recombination of two contexts of source, of course, and with the influence also of other contexts from the maternist school, etc. The logic of quadratic statements offers the possibility to introduce the concept of context, which is more or less coherent with the postmodern philosophy in some sense, but I think it is not exactly this, because here it is defined some mathematical concepts. This is not only the philosophy. Thus, the main feature of the logic of quadratic statements is the existence of different contexts. Well, now, one can consider, I will now consider the direction with respect to the MEMS, the dissemination of context, the cloning. The context can be cloned from one version to another.
C'est trivial tout ça.
The second person can take the context from the third person as an own context. This is the one way. The dissipation may have the heredity from parents to children, and also the context from many persons to another person. It is clear that there is a natural phenomenon of the fight of context. We have the context of the Western civilization. We have the constant context of other civilizations. This is the philosophical fight of ideas. Well, so I have I'm sorry, I have a version which is not complete I'm sorry, no, I'm not able to make it better. With references. So I'm sorry, I will put the references to the slides which will be published. The conclusions are that with the change of the concept of an event, from the linear concept of an event, which is standard in probability theory and also in logic, as I explained. If the concept of a event is considered as an elementary conjunction, it is possible to make a variance, to introduce a new concept of a context of an event, which is a quadratic event. Quadratic event intuitively means that we have a subset of omega, but together with its decomposition with respect to distinguishability. This is the most natural representation, logical representation of the quadratic context. There are mathematical other representations from which the term quadratic event is coming. But this is the main meaning also in probability theory and quantum mechanics, also in the extended logic. This means that you can make, for example, in logic, the indistinguishable union, where these parts are union. There is a union of parts, but without making distinguishability. This distinguishability and logic is extremely important. This means that we can consider the generalizations. As an example, I consider the concept of a cat, an animal, beautiful animal. And the concept of a cat, we have classical concept of a cat, which is corresponding to the set of all cats in the world. 1, 2, 3 billions of cats. This is a classical understanding, where this is the union of the set of all cats, but distinguishable, which means that each cat is distinguished from the another by some individual feature. But the indistinguishable union is the union of all cats, but without relation to the differences. There is an abstraction, so-called abstraction of any specifications of these cats. And what there is resting is the concept of a cat without distinguishing these individual cats. This is the logical meaning of this quadratic, of this atomic set, indistinguishable unions. This is a new concept which makes, as a consequence, dramatic changes in the structure. This main change is the introduction of context, both in logic, both in the same way in the probability theory and quantum mechanics. This so that with respect to the comparison between quantum mechanics and thinking, logic, is the following, that in quantum mechanics, it can be shown, I have shown this in the references, I'm sorry for them. They are not in slides, but they will be published in the documents. We can, all my references can be found simply on the pages of Academia Edu, Academia.edu. This similarity, I think there's a similarity, certain similarities between quantum mechanics and thinking, human thinking, is considered is the consequence of the of the fact that quantum mechanics is in fact based on the quadratic theory of events, and the generalized logic can be also based on the generalization of the quadratic events, and this makes these two quantum mechanics and the generalized logical thinking similar because their background is the same. I think that this is quite important set because up to now, this in logic, this is more new. In quantum mechanics, it was more or less also described already. In logic, this means that the generalization, the method of generalization, which is called the lambda operation in the standard logic, is the main operation, generalization, the main operation, and in standard logic, the generalizations are the structural different elements of the elementary statements. But in quadratic logic, the generalizations are equally good as the classical elements in logic. The idea is that the human thinking contains generalizations. This means, in fact, the quadratic construction of statements, the indistinguishable unions of statements.
Okay, Doctor.
That this is quite important similarity between quantum mechanics and thinking. The MEMS are the consequence of it. We can say that the MEM is the atomic statement and memotype is the union of quadratic statements. So thank you very much for your attention. I had some small problems, but I hope that the topic was understandable.
Thank you very much, Dr. Soucek. Thank you for your very detailed lecture and presentation. I guess, could you have questions to Dr. Soucek? And Dr. Soucek, could you please turn off your screen sharing so we can see each other?
Yes. And how to do this? How to do this? I have always this slides, but
no, you have to click on this two overlapping squares on. Oh yes, we are back.
Yes, we are back. Yes, thank you for helping. But I am not. I am not hearing anything.
Dr. Soucek, you have to click
on the microphone.
No, on this two overlapping squares on the right side of the bottom of your screen.
Yes. Yes.
Okay, now it's okay. Okay.
Okay, thank you.
Yeah, thank you very much. Would you have questions to Dr. Soucek?
Oh, I have one question. I'm not sure what you call a context. Is a sigma algebra in Kolmogorov space?
Yes, thank you. I have simplified the situation to the finite set, so I called about algebras, not the sigma algebras. Mm-hmm. If there are events which can be incompatible, the natural concept is the concept of the context, which is the maximal set of mutually compatible statements. This is not possible in the classical case where all statements are compatible, or in the Kolmogorov theory, this means that these compatible statements. There are incompatible sets, events. So that there could be maximal sets of mutually compatible events. This mutual set is defined by a universe. And there may be different universes and consequently different contexts. I am sorry, I could explain this on examples better, but we have no possibility at the moment.
Okay, thank you.
Thank you. Who else is ready to ask a question?
Well, a simple question maybe. The contribution of Jiri Soucek is very general. It's a kind of general frame concerning either quantum mechanics, although it's not very clear how, and the human thinking. And my question is, what kind of result can we expect from your theory?
Huh?
Even if you don't have now a concrete result, what do you expect with your theory?
Yes, thank you for the question. I understand that the approach is, as a basic, is rather general. I agree completely with you. It can be explained. I have written some papers on this, but not completely, with not complete reconstruction of quantum theory from this point of view. But in general, it can be shown that the main point, I think, that the main point of the quantum mechanics is not the complexity of the Hilbert space. This is a secondary point. That the main point is this existence of consideration of quadratic events. Because, for example, I have not cited this, there is a theorem that if one considers the probability theory based on quadratic events and consider the standard probability evolution of probability system in this theory, one obtains the real quantum mechanics. This means the quantum mechanics based on the real numbers instead of the complex numbers. There is a difference, I agree, but I think this difference is secondary. This is some more symmetry in quantum mechanics. So that it gives the representation of the quantum mechanics as a standard theory of probabilistic systems in this new probability theory of quadratic events. This is on the part of the quantum mechanics. It is not finished, this description, but it is already sure. On the other hand, this opens a new field which is analogical. There are, we have with my friends 2 papers on this extended logic. I will cite them, but this is in the progress. I think that this can give, I hope, I believe that in the future, this can give an extension of the classical model for logic, which will be fundamentally more similar, quite similar to the quantum mechanics, because these two will have the same basis in this theory of quadratic events. This is perhaps a general explanation of my ideas.
You certainly know the relationship between the so-called logic of quantum mechanics, and not the classical logic, but the intuitionistic logic. Intuitionistic, sorry. And in the last paper by Cochin, he mentions this. That's the logic where when you have A or B, you cannot decide whether A or B. And you know that's a logic where you don't have the tensum non datur, so you don't have A or not A as being always true. So maybe there is a connection between the intuitionistic logic and your quadratic events.
I must say, I was interested, not completely, in some extent, in the intuitionistic logic where I was young, in fact. And I tried to find some connection between intuitionistic logic and the logic of quadratic statements. The general idea that the double negation is not equal to the original statement applies in both cases. But I think that at the moment I'm not able to arrive at some definitive comparison between this logic and the intuitionistic logic. I think that they are different because basically the set of events are different. These two logics are different, but some features are quite similar generally. I am not. This will need more analysis of the how is called this space of equivalent statements to compare these two logics. I have not definitive results in this direction, but my opinion is that they are in fact different, even if formally they are partly similar. These two logics, intuitionistic logic and the logic of quadratic events. The precise comparison I am not able to do now.
Just a question: is the negation of a negation give the original formula? Is non-A equal to A or not? In your logic?
No, in my logic, in general case, double negation of A is not equal to A. There are some cases when if A is an atomic event, then the double negation of the A is equal to A. This is the only situation. So it is formally it is somewhat similar with the intuitionistic logic. I agree with you. In intuitionistic logic, there are that A is cannot be equal to double negation of A. This is the general rule that they are not equal. So the comparison is not completely clear for me.
Thank you.
Okay, thank you very much. And I guess we should thank you, Dr. Soucek, for your presentation.